In this video, we continue learning the data flow editor, and we'll be putting together enough data to construct a circle. And we'll want to see the circle, and so then we'll learn how to visualize the circle in the 2D Cartesian workspace. Okay, so the task is going to be to begin using graphics. That's going to have us using our 2D Cartesian workspace. And the overall goal here is to create a circle that we can visualize. So the first step is we're just going to have to learn about the coordinate system used over here in our 2D Cartesian workspace. And a good way to do that is to just start with one single point. So let's do that. You'll notice down at the bottom in the left corner, we've got a button that creates a point or a vector. We'll work more with vectors once we get a little further into the course. But this object, it's called a vec2, is able to represent a point in space. It's got X and Y coordinates. And so let's go up and get a couple of real variables that we can use to define that point. And let's just start with something real simple where we'll use the coordinate 0 and 0. So this defines the origin. And you'll notice when you furnish numerical input to this point or vec2 object, you get this square here with a V on it, and that will allow you to visualize the point. However, just clicking on it doesn't do the trick. We're going to use a modifier key. So again, let's look at our modifier keys down here in the bottom left. And so we're going to use the Alt key when we want to visualize an object. So I'll hold down Alt and just click on that V. Aha! Okay, so we've got our point now drawn over here, and we're just where you'd expect at the origin. And so the first thing we're going to learn is about the coordinates along here. So how do we define the coordinates in this space? Well, we're going to use just the pixel coordinates. This is a pixelated display. It's got a little less than 1 million pixels in it, and they're densely packed. So what if we just wanted to see how far out the point moves if we send it out to about 100 pixels? Okay, so over here for our X input, let's put in the number 100. And okay, so this shows we've moved from here to here, and so that represents about 100 pixels of horizontal increase. So now we can ask ourselves, well, how far could you go out on this plot? And by the way, I'm using the half-size version of the 2D Cartesian workspace. You may be using the full size, in which case you'll be able to go twice as far with your coordinate system. But I can sort of estimate here, I might be able to get out to about 300 for X. So I'm going to change this X coordinate to 300. Okay, so that takes us almost to the edge of the half-size window. And so the question then arises, what happens if I were to set this to be 400? Anybody want to guess? Oh, uh-oh. So what we're seeing here is something called clipping, which you will encounter when you're generating two-dimensional graphics. And so if you draw content at a point outside of the defined display, you will not see it. So let's bring this back in. Okay, back in bounds at 300. You can also, I'm going to have you as an exercise, take this point and just by modifying your X and Y inputs, move that point around the screen. I'd like you to visit all 4 quadrants, maybe visit the corners. And by doing so, you're going to learn a little bit more about the coordinate space that you'll be working in. So let's pause here and just take the exercise forward to play around with the coordinates, get an idea for how extensive the numbers are in this display system. Okay, so I've moved my point here, positive 200, negative 150. The next thing we're going to learn is that we can change the color of a graphical object. And you'll notice as part of your visualization button, you've got a little color swatch here. And just as I did before to turn my visualization on and off, I need to be holding down my Alt or Option key. You'll just notice here I can toggle the graphics on and off by hitting the V. But if I go over into the color swatch, that's nice. I get a color palette. And so I can reassign the color of my graphed object. Great, okay. Well, let's take it now a step further and go from a point to a circle. So we've got a point. In order to define a circle, let's go down to our geometric objects here. And the second button in that row is a circle. So I immediately look at my inputs here on this object. So just as I'd expect, I need to define a circle center, C, and a radius, R. And these are different size indentations. This is just indicating a real number or a scalar, a single numbered object is expected for the lower input. And upper input is expecting a structured object, which is what we have here with our point. So let's do this. So let's connect up. That point is defining the center of our circle. And I'm going to stretch my input edge here so I can accommodate a radius. I'll need a real number to do that. So just follow along with me. Okay, and we're not going to see the circle until we've furnished a numerical input for the radius. So I'm just going to go with 80. So it's equivalent pixel length of 80. And now I've got my visualize button. I'll do an Alt click. So now I have a circle. I can visualize it. And if I choose to, I can change the color, again with an Alt click on the color swatch. I'll make it green. There we go. And you'll also notice here, all of these numbers are editable and will enable recalculation. So if I want to make my circle have twice as much size, I'll just enter a 160. There we go. And again, if I want to move it in closer, I can essentially just give myself different X and Y coordinate for the center. Okay, so what have we learned here? We've learned how to build up a point using a Vec2 object, furnishing it with real number coordinates for X and Y to define the point. We've learned how to define, how to make it visualized by using our V button in conjunction with holding down our Alt or Option key. We've learned how to use the color swatch with an Option click on it. And we've learned how to build up a circle using our given geometric object button here. representing a circle, furnishing a center, and furnishing a radius, and then being able to visualize that circle and give it a color. And then finally, we've experimented with dynamically changing any of these numbers and immediately getting our circle recalculated as a result. Okay, so we're about ready for a break. I'm going to show you next how to save your work in the editor, and it's all highly automated. When you're ready to quit the app, all you have to do is quit the app. Everything, all your work in the editor is automatically saved and will be restored for you when you relaunch the program. So let's go through that together. You've got your data flow, which generates a circle with your choice of colors. And to quit the app on Windows, you can close it by closing down either of the two windows. In the Macintosh, you've got a menu quit up at the top bar. I'll demonstrate the quit by using the Close Data Flow Editor button right here. And so I'll just relaunch my Data Flow Geometry 2D app. I can do it either from here or from the dock or in Windows, the taskbar at the bottom. And yes, so we get back our data flow just as we left it at the time we quit. Okay, and so we're all done here in preparation for where we're going next. We can just clear our data flow editor and we'll just send it to trash. Now that you've got the hang of how to assemble modules into a calculator using Snap-to links and how to generate graphics, we're going to show you an even more powerful way to pipe data between modules that gives you total freedom of layout.